Okay. Here's what we're going to do today. We're going to cover a number of problems, and then tomorrow we're just going to cover two, and you're going to be given the rest of the time to work. And in fact, I'm going to give you Friday. Friday's a work day. I'll actually already have the study guide prepared for you so you can start practicing some more of these related rates problems. Raise your hand if you were able to get through problems 1 through 7 last night. So you're feeling confident, as in like I own that? We're trying to turn over a new stone here? All right, good. So homework done right away is a big deal, and same thing will go for tonight, okay? So I think is it tomorrow? Okay. 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 Oh, did I not give you that? I give you the worksheet though, right? Or the notes? Okay. All right. So let's move to this situation. We have an airplane's traveling east, and then we have another airplane traveling north. It says that they're traveling at certain rates. So we have 600 miles per hour, and we have 750 miles per hour. It says if they left the airport at the same time, how fast is the rate of their distance apart increasing after 2 hours? So, thank you, Pythagorean Theorem. So I'm going to list this as N, I'm going to list this as E, I'm going to list this as D. So we'll write in terms of Pythagorean Theorem, E squared plus N squared is equal to D squared. For northeast and distance. So, yep. So I'm going to write both of these pieces. We have north and we have north prime. Which one are we given right off the bat? North prime, which is 750. Is everybody clear that that's 750? So if they've been traveling for 2 hours, how far north has it gone? 1,500 miles. Is anybody curious how we came up with 1,500? 2 hours at a rate of 750 would travel then 1,500 miles. Is that better? Okay, so then east and east prime. What is east? Prime. 600, so east would then be 1,200. So now I have distance and distance prime. Which one am I looking for? Distance prime. So let's take the derivative with respect to time of e squared plus n squared equals d squared. What is the derivative of e squared? 2e prime plus 2n prime equals 2d prime. I could take the 2's off, couldn't I? Just divide through by 2. So now we have e times e prime plus n times n prime is equal to d times d prime. Nice thing is I know what e is. It's 1,200 times 600 plus n is 1,500 times 750 equals d times d prime. Uh-oh, we haven't figured out d yet. Can you figure out the current distance? How? What do I use for n? Do I use 1,500 or 750? 1,500, that's the distance. Adam, take it away, bud. 1,500, 1,200. We got 1920. So we got 1920 d prime. So I'm going to solve. I have 1,200 times 600 plus 1,500 times 750. And I get this, and I'm going to divide by 1920. I get 960. And what is the label? Miles per hour. Kind of neat, huh? All right. Good. You do realize, though, that last year when we did word problems, that we maybe were a little bit, we didn't like them as much. And so with some practice, all of a sudden you start to see, you may not draw the 4 boxes, but you start to see the 4 boxes a little bit in your head in terms of how it's organized. And so there's some really cool problems. We're going to try a few more today. I think the best problems are tomorrow. But and then you're going to see some optimization problems later on in this unit that are very cool as well. So we have a ladder is 12 feet long. It's sliding down the side of a building. So got a building. It's got a door. We'll say this is Catherine's house. There you go, Catherine. Okay. Oh, okay. So, all right. Well, okay. We'll pick up with this when we get back. Yeah, so. All right. I would call this X, I would call this Y, and the length of the ladder is 12. It says the ladder is 12 feet long and sliding down the side of the building. The base of the ladder is moving at a rate of 1 foot per second away from the wall. How fast is the top of the ladder falling when the base of the ladder is 10 feet from the base? Again, I'm going to set up X squared plus Y squared is 144. Does that ever change? No, so I can plug it in right away. But do X and Y change? Yes. Do I know X? Do I know how far it is from the base of the wall? It's 10. Do I know X prime? 1. Do I know Y? I'm trying to find Y prime, right? Let's see if we need to find Y or not. I take the derivative with respect to time of X squared plus Y squared is equal to 144. Derivative of X squared, 2x X prime plus 2y Y prime is 0. So 2 times 10 times 1 plus 2 times, well, now I do have to find it, don't I? I have to find what Y is. How do I find what Y is? Plug it in. So I have 10 squared is 100 plus Y squared is equal to 144. So Y squared is equal to 44. So Y is equal to 2 roots of 11. So I have 20 plus 4 roots of 11 Y prime is equal to 0. So 4 roots of 11 Y prime is equal to negative 20. I've got negative 1.5. Y prime is negative 1.51. What's my label? Why is it negative? It's falling down. Water is being poured into a cylindrical container. At a rate of 6 cubic centimeters per second. The radius of the container is 3. The height of the container is 6. At what rate is the height increasing when there's 24 cubic centimeters of water? You try to take ownership of this one. What's my formula? Yep, volume is equal to pi r squared times the height. Now what do you want me to do? Okay, I know what h is. Says the height is 6. Now, the height is 6 of the container, right? But is that the height of the water? No, are we wondering about the water or the container? We're wondering about at what rate the height of the water is increasing. So therefore, I will not use the height is equal to 6. I know r. The radius of the water is 3. I know the volume. 24. And I know v prime is 6. If you take the derivative right now, yes, we're trying to find h prime. If you take the derivative right now, what rule do you have to use? Product rule. I don't want to do it. Sometimes you can't avoid it, but I don't want to do it. I have to ask myself, is the height changing? Is the height of the water changing? Yes. Yes, it is. Is the radius of the water changing? No, it is not. So what can I plug in? I can plug in 3 because it is not changing. So I can plug it in right now. I get the volume is equal to 9 pi h. Now do I have to use the product rule? No. So we take the derivative with respect to time of v equals 9 pi h. Derivative of v. Derivative of 9 pi h. 9 pi h prime. And we know that v prime is 6 equals 9 pi h prime. Divide by 9 pi. And I get 2 over 3 pi is equal to h prime. Or 2 over 3 pi what? Okay, we're going to do 2 more. We'll do 7. We've already done 8. We'll do 7 and 9. This one is an application to physics. Boyle's law. You guys used that before? No? Oh. Boyle's law states that if the temperature of a gas remains constant, the pressure and the volume of the gas satisfies this equation. PV is equal to C, where C is constant. The volume is decreasing at a rate of 10 cubic inches per second. How fast is the pressure increasing when the pressure is 100 pounds per inch squared? And the volume is 20 cubic inches. That sounds just absurd, doesn't it? The idea is that we have, say a balloon, and you are going to compress the volume. So you're going to take that balloon and you're going to try to make it smaller. What's going to happen to the air inside? It needs somewhere to go, doesn't it? The pressure of the air rises till finally it'll break the balloon, right? So that's what we're seeing is happening here. The other way that you can increase the pressure is you can heat it up. And the hotter you make that substance, then the more it will want to expand. So we simply have this formula, P times V is equal to a constant. Now, we don't necessarily know what that constant is. We can figure it out, fortunately, but it doesn't really matter because it's a constant. It could be 100, it could be a million, it could be 1,000. Doesn't matter, it's a constant. Do we know the current pressure? 100. We know P prime. It says how fast is the pressure increasing? So we are looking for P prime. What is V? And what is V prime? 10. Negative 10 because it is decreasing. So I take the derivative with respect to time of PV is equal to C. Is the pressure changing? Yes. Is the volume changing? Yes. So the volume is decreasing, and it's wondering how fast the pressure is increasing. So they are changing. So I can't just plug something in. So I use the product rule. What is the derivative of P? Times V plus P times is equal to 0. P prime is what we're trying to find, times V, 20. And then plus negative 10 times 100 is equal to 0. Or 20 P prime is going to be equal to 1,000. P prime is equal to 50. 50 what? What do we measure pressure in? Pounds per inch squared. And then it's with respect to time, so it's going to be pounds per inch squared per second. So the way that you write that is just 50 pounds per inches squared times seconds. You put them both in the denominator. Because when you multiply by the reciprocal, the label would be in the denominator. One more. Number 9. I love this problem. Corn is being piled into the shape of a cone. Are there any farmers in here? Corn, soybeans? Now you can do this problem at home. Okay? I want you guys to try it. Do an experiment. See if it works out right. Just being piled at a rate of 12 cubic feet per minute in the shape of a cone. I need to figure out the volume of a cone first. Does anybody know what that formula is? 1/3 pi r squared h. Which you may wonder how we even come up with the formula. You use calculus to find it out. So we're not that smart yet, but someday we will be. It'll be really cool. Okay. Do I know the current radius? What is the current radius? Current radius is 4. Do I know the current height? 6. I know V prime is 12. What am I trying to find? Trying to find H prime. It says, how fast is the height of the pile increasing? So H prime is equal to something. Is the radius of the pile changing as you add more stuff to it? It is. As you spill more corn on top, it will slowly draw this out. Is the height of the pile changing? Yes. Is the volume of the pile changing? Yes. So right now, I can't just substitute something for R or H because they're both changing. So what rule would I have to use? The product rule. But this is a problem because if I use the product rule, would everybody agree that I'm going to come up with an R prime? I'm also going to come up with an H prime. It's good that we come up with an H prime. We want H prime, but we don't want the R prime because we have no idea how to find it. So what do we do? This cone will always grow in proportion to itself. So meaning if the radius was 8, then the height would be 12. So what we can do is just set up a basic proportion. The radius divided by the height is equal to 4 over 6. Do I want to plug something in for R, or do I want to plug something in for H? What do you think? If I plug in something for H, then I'll have an R, and I'll come up with R prime. But if I plug in something for R, I'll have H's, and I'll come up with H prime. So let's solve for R. We got 6R is equal to 4H, and R is equal to 2/3 H. No, thank you for answering it. No, you're not. So I'm going to plug that in right there. And when I do, I get volume is equal to 1/3 pi R squared. 2 over 3 H squared times H. Or volume equals 1/3 pi. What's 2/3 squared? 4/9 H squared H. Don't just leave it like that. Actually write it as one nice piece that's tied together with its variables and everything. So 1/3 times 4/9 is going to give me, so I have 4 pi over 27 H cubed. The derivative with respect to time of volume is V prime equals, when I drop the 3 in front, that 3 over 27 will reduce to 1 over 9, correct? So I have 4 pi over 9. H squared, H prime. So there's my H prime. What is V prime? 12 equals 4 pi over 9. H is 6, so I have 6 squared times H prime. Or 12 equals 4 pi over 9 times 36. 36 divided by 9 is 4, so I have 12 is equal to 16 pi H prime. Divide both sides by 16 pi. 12 over 16 would be 3/4. So 3 over 4 pi. And then what is our label? Feet per minute. Good. That should be able to take you through the following problems. You should be able to do 8 through 12. And you should be able to do 16 and 18. And then we will pick up tomorrow with 2 more problems. You have the rest of the hour to work. And I'm going to give you time to work on a study guide on Friday as well. Okay? We are going to cover 2 lessons next week that are significantly easier than what we're doing right now. Did I say significantly easier? I meant significantly easier. So, if you can understand the problems that we're doing, you're going to be in great shape for your test.